Hey guys, I have a question whose answer I don't really have, but I have some thoughts to share and I just wanted to see where it would go from here. The question is, why does optical interference take place when no light is present? And what do I mean by that? Well, let's take an example. Let's say we've got an AR coating, anti-reflection coating. That's this material right here with index N1 sitting on glass with index N2. They're both inside air with index 1. We're going to do the math for interference by cheating a little bit. Actually, a lot, because I'm going to make the gross, disgusting assumption that there's no multiple reflections taking place in this interface. Actually, there is, but let's just assume there's none. So the only bounce of light takes place at the first surface, giving rise to I1, the intensity of light bouncing off, and I2, the intensity of light bouncing off the second interface. Right? By intensity, I mean the time average of the square of the electric field amplitude with the phase. Okay, so now the interference equation is basically this: I1 plus I2 plus this, and the phase difference has to be pi because you want destructive interference with an AR coating, right? So the total intensity will sum up to be 0, which is here, okay? And because of the pi phase shift, we got negative here, and if you just pause this screen, you'll go over the math, and you'll see that they all work out to be this. If you recognize the algebra inside here, solve for n1, we'll get this, which is interesting because this is exactly the result you get if you do not assume that there are no multiple reflections inside this medium. Anyway, n1 equals square root of n2. If n2 is about 1.52, then the square root of that is about 1.2 something. And the closest material to that is magnesium fluoride, unfortunately, with index 1.3 something, which is pretty far from 1.2. But anyway, so you apply your magnesium fluoride right here, and you get your destructive interference in this space right here. Okay, great, excellent. So the light goes away and passes through instead, right? That's transmission. That's the characteristic of interference, or property of the law of conservation of energy, right? Energy gets redistributed from areas where you got destructive interference to areas where you got constructive interference, so that the sum total of the energy is constant. Okay, great. But there's no more light up here, right? The light has gone down. So if there's no light up here, how do you interfere? Because interference takes place when we sum up the intensities right here. Now there's no more light there. So what is happening here? Okay, so the only thought I have for this is that probably intensity, which is the time average of the blah 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 blah, is different from electric field amplitude, right? Amplitude and intensity are obviously mathematically different, but they're also different in the following sense. You can have amplitude present without the intensity, like sort of like quantum field theory, which is an area I don't know anything about, but everyone has heard of vacuum fluctuations. The vacuum is not fluctuating, but there's matter in vacuum, and matter has particles like electrons, and when they shake around, their fields are also shaking around, and their fields permeate all through vacuum and space. So they're shaking, and they trigger processes like spontaneous emission, for example, right? So it's vacuum like field fluctuations. So the fields can be there even though the light isn't there, right? So that's interesting. Okay, well, that's the only thought I have there, except for one more thing I'll leave you with, which is that let's say I'm in a room. I'm in a room, a dark room, and there's a crack in a wall where light passes through. Now I don't see the light. I won't see the light unless there's like dust, like a lot of dust in the room, right, scattering the light to my eyes. But so when that happens, I see a beam of light coming through the crack. Uh, but the question is, am I seeing the light or am I seeing the dust? Right? Because without the dust, you don't see anything. Even if I turn my eye to the sun and look at the sun, I see brightness. But am I seeing the light or am I seeing the sun? I don't know. All right, beats me. And with that, thanks for your time. Bye bye.